Good morning, everyone, from City of STEM and the Columbia Memorial Space Center. How are you guys doing? My name is Ben, and I run the Columbia Memorial Space Center. We're a space museum and hands-on science learning center, like a science museum, basically, down in Downey, California, not too far away from where you are. I hope you're having a great morning so far in class. Hope you're learning a lot and having a good time. I think for a lot of you, it's going to be spring break next week, so that's exciting. But today we wanted to bring you some hands-on science straight into your classroom. And this is part of something we call City of STEM. City of STEM is a huge program that happens throughout the LA area, throughout Southern California, that brings together hundreds of STEM people, science, technology, and engineering and math people, to bring programs to you. And in fact, this Saturday will be the big event, and you can watch all day. You can watch science stuff all day, technology stuff all day, engineering stuff all day, and math stuff all day. It's going to be super great. I'm going to tell you more about that. And in fact, by the way, on Saturday morning, we're going to have a conversation between Bill Nye the Science Guy and Kareem Abdul-Jabbar from the Lakers. It's going to be pretty great. But this morning, we wanted to bring you a couple of hours of fantastic STEM. But before we do, I want to tell you a little bit of something about where I am and what we do. Like I said, we're the Columbia Memorial Space Center, a space museum, and we put on the City of STEM with about 100, 200 different partners. But how about, let's watch a little video. This astronaut visited us a couple of years ago, and he does a pretty good job showing you what the Columbia Memorial Space Center is all about. Let's hear it from astronaut Leland Melvin.
We are here at the Columbia Memorial Space Center. Well, the families of the Columbia crew told me the night of the accident that we must carry on their legacy and honor them. And that's exactly what we're doing here at the Columbia Memorial Space Center. We're honoring the legacy of those that have fallen by helping inspire the next generation of explorers through STEAM education, science, technology, engineering, the arts, and mathematics. And having kids coming off the street, having kids being able to do missions, having kids being able to touch space in this environment and be inspired to carry on that legacy of those that have fallen. A site like this will help, those kids and get inspired and know that they can continue to carry themselves on to Mars or to the moon or flying on the Orion capsule one day to an asteroid maybe that can help us, mine an asteroid for minerals and, bring back the benefits of space travel to the planet. So this is the springboard for curiosity and innovation and inspiration right here in Downey, California.
There you have it. That is the Columbia Memorial Space Center, and brought to you by one of the astronauts who flew into space on the space shuttle a couple of times. Actually, Leland Melvin is just one of the astronauts who visit the Space Center pretty often, and you can come and visit us, or at least take part in some of our online programs year-round. Before we get into the first part of the day, though, I want to let you know about what we're going to be doing. So over the next couple of hours, we're going to be presenting hands-on, awesome science from aerospace things and space things all the way to nature stuff. We're going to go into the ocean, all from organizations around Los Angeles who do science, engineering, technology, and math. We've got something from the Columbia Memorial Space Center coming up. We've got something from the Emerald Bay Outdoor Academy. It's going to be fantastic. From Crystal Cove Conservancy, again, another sort of ocean and nature conservancy group. The Discovery Cube, there's two locations of Discovery Cube, one in the Valley of Discovery Cube LA up in the North Valley. And also then the Los Angeles Maritime Institute is going to be taking you on a ship. We've got a great morning planned for you. I hope that you watch it, as much as you can, and I hope that this is a great way to enhance your classroom day today, a couple of days before spring break. So again, good morning. It's City of STEM for you in class, and we're going to start off with a bang to really wake you up. Jared from the Columbia Memorial Space Center is here to do some demos and talk about space with you. Enjoy.
Well, hello everyone, and welcome to the Columbia Memorial Space Center, specifically outside in our delightful amphitheater that we have here on this beautiful Wednesday morning virtual classroom that we've got here. My name is Jared. I'm one of the activity specialists here and one of the aerospace educators as well. You may recognize me from Space Center Live, which we're going to have one on Friday talking all about Mars Perseverance, so if you want to check that out. Highly recommend it. 2 p.m. Pacific Daylight Time. I hope to see you there. But today we're going to be doing some experiments. We're going to actually do an experiment that you can do at home, and then we're going to do an experiment that you can't do at home. Now, in science, when you are going to do experiments, you need to make sure that you take the proper precautions. So things that are like on your wrist or other stuff like that, you're going to want to make sure to put that somewhere safe. And in addition to that, anything that can inhibit you, such as say like keys on your sides or other stuff, you're going to want to put that into some proper places as well. But our first experiment today is actually an experiment that you can do at home yourself. And this is it right here. Yes, all you need are film canisters, water, and effervescent tablets. So yes, if you have a sort of like if you need antacid relief, and you have some of these hanging around at home, you can actually do an experiment that we're going to try out here in just a second. So what are we going to do? Well, here at the Columbia Memorial Space Center, guess what we talk about? That's right, space. And how do you get to space? Because you can't just get in an airplane and go to space. There's not enough energy expended by an airplane to get you into space. So how do you do it? Well, you use rockets. And what are rockets? Well, first of all, rockets, very cool machines, also very big machines as well. And they are systems that put fuel and oxidizer together. So fuel is something that burns, and oxidizer is something that helps the fuel burn even more efficiently. So in most cases, like if you say, you take a look at SpaceX's Falcon 9 rocket, so it's kind of the rocket that a lot of us are familiar with nowadays, their fuel is what they call RP1, rocket propellant 1. It's a very highly refined type of kerosene. So that burns. And then their oxidizer is liquid oxygen. So they literally take oxygen, you condense it down to a very cold temperature. For SpaceX, it's minus 300 degrees Fahrenheit, just a little bit below that. So very, very cold. You can actually make that gas a liquid. Now today, unfortunately, I have neither RP1 nor liquid oxygen with me, because both of those, I mean, first of all, you just don't really want RP1 hanging around. It looks cool, but at the same time, you just don't really want it hanging around. And then liquid oxygen, it tends to ignite on contact with certain things. So we're just not going to have it here today because I enjoy being one piece. So what we're going to be using today instead is we are going to use a principle of rocketry, which is the generation of pressure. Now, not necessarily saying like, you need to get that done by 3 p.m. today kind of pressure. We're talking about actual pressure, sort of the pressure that you and I experience when, say, we go a little lower than sea level, or when your ears pop. We're going to be talking about that kind of pressure, because that's essentially what a rocket is. You take the fuel, you take it with the oxidizer, you combine it, you ignite it, and when it ignites, it expands very, very fast. It generates a lot of pressure when it does that, and then you aim that expansion in the correct direction, and that is literally what a rocket is. So essentially, it's a boom, but we have a very controlled boom with it. And to just make sure that we're going to have a controlled boom here today, we have some very simple supplies, as I just talked about. So you're going to need some film canisters. And if you don't know what a film canister is, that's A-okay. You probably know someone who's old enough to know what a film canister is. Back in the day, there was this stuff called film, and you used to take images on a film camera with it. And after your vacation, when you would take those images, you'd then take it somewhere to get it processed. And then you'd have like 2 or 3 days you'd have to wait before you actually got to see your pictures. Not like today, which is much nicer. We could see things instantly and just share it everywhere. Back in the day, you kind of just had to, that's just the way it was. So you'd put your film in these little canisters and it would protect your film. So we're going to use these as our little rockets today. And the way that this is going to work is that I'm going to put some water inside of here. So I'm putting some water inside of my film canister there, right? We got a little bit, that's a little too much. Pour a little out for that right there. So I've got my water in my film canister right here. And what I'm going to do, I'm going to take a tablet here, one of these effervescent tablets, and I'm going to drop it inside of the film canister right here. And then I'm going to put the top on it, flip it over very, very quickly, and walk away. And it should take off, because as the pressure increases, so as our tablet here gives off those little bubbles that make you feel good when you drink the antacid, but instead, we're going to be using it to generate propulsion. So we're going to use it to actually move it. So why don't I do an example for you right now? So see, I got this right here, and I'm going to go ahead and just drop it in there, right? Okay, so we're starting to bubble, And now I'm going to put the top on, step back, and let's see what happens. Let's see how long it takes. Oh, look at that. And that went up, I'd say about somewhere in the order of like 20, 25 feet. So that's a pretty good one, wasn't it? Yeah, that's pretty good. I quite like that. Now, obviously, don't do this indoors because, you kind of get going pretty high there. And I think one of my favorite things about this, too, is the fact that there really is no countdown. You just kind of got to guess as to when it's going to fly. So that's adds to the excitement of it, because usually in space flight, we don't guess when we're going to launch things. We have very specific times. So now what I'm going to do, I'm just going to do it one more time, so that way you all can be a little more familiar with the process of it. So I'm adding some water, right? I'm going to drop my tablet in there as soon as I get my tablet out. Very good. And you don't have to get the big tablets like I did. I got the big tablets because I wanted big flying rockets for y'all today. So drop the tablet in, put the top on, turn it over, step away, and eventually it will launch soon, just like that. And it goes, oh, hey, right in there, looking pretty good with that there. So very, very nicely done with that right there. Now, what if we controlled the amount of water that we put inside of our container there? What if we put like a lot of water in one and then a little bit of water in the other? What do you think is going to happen to them? So what is your hypothesis? Is the container that has more water going to fly higher into the sky? Or is a container with less water going to fly higher into the sky? And why do you think that as well? Why would your film canister that has more water fly higher? Or why would your film canister that has less water fly higher? These are things that we often ask ourselves when we're designing spacecraft or rockets, except it's not sort of, why. We're not sort of asking why, would this film canister fly higher than the other, but we definitely do ask ourselves things in the design process that allows us to figure out, okay, well, maybe we should be doing this, this, and this, instead of looking at it in this way. So I want you to go ahead and kind of figure out your hypothesis. So a hypothesis is a very educated guess. And I want you to kind of figure that out, which one do you think is going to fly higher? Do you think that the rocket, our little rocket here that has less water is going to fly higher, or is our rocket with more water going to be flying higher here today? Well, why talk about it when we can actually do it, right? I mean, that's kind of the point of experimenting. So, just for a little recap, here's our rocket with the small amount of water. Here's our rocket with the large amount of water. You can see the one with the large amount of water is almost to the top. The small amount of water is maybe about a quarter of the way up there, and it's the least I've done today. So what I'm going to do, I'm going to drop the tablets in. Nothing changes between them until I put the tops on them. I'll put the tops on them, and then I'm going to run away very, very fast. Here we go. Which one will fly higher? Oh, there goes our lot rocket. Oh, there goes our small water rocket. Wow, so the small one, the least amount of water, that flew pretty darn high into the sky, huh? Yeah, so why is that? Well, if it's building up more pressure inside of it, if it's building up more pressure inside of it, it's going to have more energy to release once the top finally pops off. So what if I put like a really small amount of water inside of this, like just enough to barely get our little tablet ready to go here? How high do you think it's going to fly there? Or how fast do you think it's going to take off? I think it's going to go really, really high. So why don't we figure this out? I'm going to drop it down to maybe just enough so that if I put the tablet in sideways, it'll actually fit. So here we go. All right, I dropped it in sideways. Excellent. I'm now going to step away and let it fly. Let's see what happens here. Oh, nice. And that classic pop that comes with it as well. I quite like that. Very, very good. Now, I'm going to go ahead and just start setting up as many as I can and dropping as many as I can and putting some more in with as many as I can. And Yeah, this should be a lot of fun with this here. So just get some water in there, just like that. We'll kind of do our little grand finale here with our film canister rockets. And remember, this is an experiment that you can definitely try at home, so feel free to do so. I know most of the time they say, don't try this at home, but guess what? You can try this at home. In fact, you should try this at home. Just remember, do this outside, and also, make sure that you do have adult supervision. Even if you're an adult like me, you still need adult supervision. That's for sure. All right, so we're going to go ahead and get this out. Get these ready right here for me. Fresh, effervescent tablets. Let's just go ahead and start dropping them in, and we'll do our nice little grand finale that we have right here. I'll just start setting them up, and they're going to start flying. And right above me there. There we go. Still going. Oh, boom. Boom. Wow, they're really popping off today, aren't they? Yes, they are. They are looking good. Let's do that one, and then I got one more right there. And let's see them. Oh, pop. That was good. And I got one more. Oh, boom. Very, very nice. All right, so now that was our little film canister rockets that we have right there. So very, very cool. Of course, if you got to clean up a little bit, don't forget, clean yourself. Make sure that you're nice and good for your next experiment if you do have one. In my case, I've got a pretty cool experiment going on right here, although cool in the sense of this looks cool, but it's definitely going to be a hot one because let me tell you, this experiment, this really sets the crowd alight when you do this one out and about. So this is an experiment that I like to call fire hands. And what it does is it demonstrates something that water can do. So a lot of people don't realize that water can act as an insulator. That means water can be very, very good at preventing things like heat from getting through. Water is great at absorbing heat. And you've probably seen this, with instances like ice melting and other things such as that. So what we're going to do now, I've got some dish soap and I've got a pan here full of water. Now remember, this is an experiment that you definitely cannot do at home. This is sort of something that the adults can do. And in fact, to kind of give you an idea of what's going on, our assistant out here, Kevin, and Jessica, we've got fire extinguishers ready to go for this here because this one's a fun one. I'm going to go ahead and soap into the water right here. So there we go. I think that should definitely be enough. And then we're going to just kind of stir it a little bit, stir it up, agitate it, get it mixed in there. Ooh, oh, very good. Oh, yeah, look at that. That's getting very, very soapy. So remember, wash your hands. It's very important. Wash your hands. All right, so I'm going to clean a hand of soap right there just to make sure everything's good with that. And to demonstrate the Leidenfrost effect, I'm going to do something a little interesting here. So the Leidenfrost effect is when you have something like water on a surface, and you have a very hot object or a very hot surface, and the water actually prevents that object from being burned. So you can imagine if you have a very hot frying pan on an oven, and you were to throw some ice cubes onto that frying pan, you'll notice that they don't stay in the same spot. They kind of move around, right? And they move around because there's a little invisible layer of water that forms underneath the ice cube on the frying pan. And that allows those ice cubes to kind of skid around. And what I'm going to be doing today, I'm going to be doing that, except I'm going to be lighting my hand on fire and being A-okay with that. So I know most folks would probably not be A-okay with their hand being lit on fire, but I'm a little bit different than most folks, which is kind of how things go with me. So the way I'm going to do that, a fun can right here. I'm not going to say what's in it, but some fun stuff in here. And I'm going to put it inside of our soapy water right here, and it's going to make some bubbles. And I'm going to grab those special bubbles, and then I'm going to light those special bubbles on fire. So it's going to be pretty fun today. I really like doing this one. Let's go ahead. I'm going to make my special bubbles right now. So there we go. That's looking fantastic. I love bubbles that look like that. Now what I'm going to do, I'm going to dip my hand in here, going to protect it with the water, and then I'm going to grab some bubbles and light them on fire in 5, 4, 3, 2, 1, and just like that. So pretty cool, huh? See that? I didn't even get burned at all. Now that was hot. I felt it. I was like, whew, man, you feel that heat? It's not just because it's outside right now. It's because that got hot. So you want me to do it again? I should probably do it again, right? Because people always love it when I get to do this one. So this is a very fun experiment, I got to say. So now remember, this is an experiment that you do not do this at home. I have done this many a time. As makes me a trained professional. Well, we'll find out after the second one, right? So here we go. 5, 4, 3, 2, 1, and woo! That was hot. So that's pretty hot. So that one, I actually felt the heat a little bit on my hand, but of course, you know, we got that water there to help chill it out just a little bit. And again, when I light my hand on fire, the water that I have put on my hand from dunking it into this right here, that allows the heat to go into the water on my hand. So the heat doesn't go into my skin or into my hair and burn either my skin or hair off. It actually allows it to be a-okay where it's at. So why don't we do this one more time? You guys want to do it one more time? I bet you want to do it one more time. I want to do it one more time. Let's do it one more time, okay? Except we're gonna go a little big here with this one. So I hope everybody at home is ready for this. It's gonna get a little toasty out here today. Okay, looking good there. All right. So everybody ready for our last run of the fire hands here in 5, 4, 3, 2, 1, and woo! Thank y'all so much for stopping by and visiting with me here today at the Columbia Memorial Space Center. We hope that you have a very, very fun City of STEM coming up, and also hope to see you at our little Space Center Live on Friday, where we're going to be talking about the Mars rover Perseverance. So thank you all so much for stopping by with me, Jared. I hope you guys enjoy the rest of our program. And remember, enjoy science and keep exploring.
All right. Jared, thank you very much. That's how we like to wake up in the morning at the Columbia Memorial Space Center. A little bit of science, a little bit of fire, a little bit of safe danger. Jared's doing well. But thank you. Thank you very much, Jared. And I hope you guys like that. Hey, I want to do a quick shout out. Looks like we have Florence Avenue Elementary School watching us out there. Thank you very much, Florence Avenue Elementary School, for sending us some stuff in the chat. Those of you who are watching, if you want to interact with us through the YouTube chat, we are monitoring it, and we'll do a shout out to you too. You know, today is all a part of the City of STEM Science Festival program, which really officially kicks off on Saturday with 21 hours of STEM content, an exclusive conversation with Bill Nye, the science guy, and Kareem Abdul-Jabbar, a Lakers legend, talking about STEM. We've got an astronaut who's going to be on. We have the woman flight director who just landed a rover on Mars. It's going to be a great day on Saturday. But also Saturday officially kicks off the City of STEM Innovation Challenge. Now, this is for the middle school students out there. This is a challenge for all middle schoolers in Southern California to think of how you would innovate Southern California, how you would innovate your city in LA and make it a more sustainable place in the future. All we ask is that on Saturday, March 27th, coming up, between Saturday and actually after that, you can register yourself or your team to submit your idea for the City of STEM Innovation Challenge. You submit a 2-minute video with your idea, and you send it to us. And by the end of the month, we'll be picking a winner. So to explain a little bit more, here's a little video about the Innovation Challenge that hopefully will get you excited.
The 2021 City of STEM Innovation Challenge Sustainable Solutions is calling all Los Angeles County middle school students to help create a more sustainable LA. LA is the city of champions, but even champions face challenges like wildfires, traffic, and air quality. But bold solutions can come from anywhere, and we want to hear from you. Entering to win is as easy as 1, 2, 3. 1. Gather a team of 1 to 5 students from your school and create an idea for a more sustainable Los Angeles. 2, create a 2-minute video that identifies the problem, the solution, and the potential impact for Los Angeles. Be sure to include the STEM needed to develop the solution. 3, ask your parent to complete registration and video submission at cityofstem.org/innovation-challenge. The grand prize team will spend a day touring Los Angeles' top tech companies and will present their winning idea to STEM influencers, including me, Allie Ward, science communicator and host of Did I Mention Invention on the CW. LA needs your ideas to bring about a more sustainable future. Don't delay. Get started today.
All right. The City of STEM Innovation Challenge. Do you accept the challenge, middle schoolers? If so, make your video, send it to us, and by the end of the month of April, we will have picked a winner, and you could be innovating the city of LA for us. So, again, I want to do a shout out to Florence Avenue Elementary School. Florence Avenue, woo! Thank you for watching. Please, the rest of you who are watching, send in the name of your school, and we'll mention it this morning. I hope you guys are having a good time, but you know what? Now it's time for even more STEM content from the LA region. I want to introduce the Emerald Bay Outdoor Academy. Emerald Bay is going to be doing an awesome hands-on activity for you guys this morning. Emerald Bay is this sort of outdoor education camp based on Catalina Island, but they do things all over Southern California. They're a wonderful group, and Burton Miller will be leading you through. So take it away and enjoy the Emerald Bay Outdoor Academy.
Hi, everybody. My name is Burton, and I'm with the Emerald Bay Outdoor Academy. We are a youth science program on Catalina Island. And today we are going to learn the story of the Catalina Island fox and learn how to make an origami fox out of paper. All right, let's go to the next slide and learn, where is Catalina Island? So it's 26 miles off the coast of Southern California. And as you can see in the picture, that is Catalina Island compared to the Los Angeles area. It's one of 8 islands that makes up the Channel Islands, and it's 22 miles long and 8 miles wide at its widest part. Let's go to the next slide. So Emerald Bay is known for our beautiful blue-green waters, which you can see out there in the picture of the bay. And on a visit to Emerald Bay, you might find yourself snorkeling through a kelp forest, or meeting a sea cucumber or a bat star in the touch tanks, or kayaking through the bay to see the brown pelicans in the cliffs above the ocean. All right, next slide. So one of our favorite critters that you might find on Catalina Island is the fox. So today we're going to share the story of the amazing Catalina Island fox and then teach you how to make one using only paper. So the scientific name of the fox is Urocyon littoralis catalinae. And these foxes are found on Catalina Island and nowhere else in the world. So the word for that is endemic, when something is found naturally in one specific place and nowhere else. So they're actually smaller than the foxes you might see on the mainland, because over time they've adapted to their life on the island where there's less food. And these foxes almost went extinct. So let's go to the next slide and learn about their story. So in 1999, there was a virus that swept through the fox population, and the virus was called canine distemper. And it's a virus that affects various types of dogs, of which foxes are canines. So their population before the virus hit was over 1,300, but then in less than a year, their population crashed to less than 100. So from 1,300 to 100 in less than a year because of the canine distemper virus. So let's go to the next slide and see what the scientists did in order to help save the Catalina Island fox. So they used 3 methods and acted very quickly in order to save the island fox and bring them back. So the first thing that they did was to develop a vaccine against canine distemper so they could vaccinate the healthy populations that had still survived. The second method that they used was they started a captive breeding program. So they took healthy foxes and had them start fox families in protected pens where there were over 30 pups that were born in captivity and then released out into the wild. And then the third method that scientists used to help bring back their population was called translocation, or bringing foxes from one part of the island to another. Because one part of the island was hit way worse with the disease than the other part, so they took some foxes from the part of the island that was hit less and brought them over to help balance and replenish the population. So let's go to the next one. And today, there are even more foxes alive than there were before the virus hit. We're happy to report that the foxes are healthy again and their population is growing. So it's over 2,000 foxes now living on Catalina Island. So today, we're going to show the foxes some love, and we're going to learn how to make one using only paper with our origami project. So the next slide will have the materials. All that you need is a piece of paper. You can use any color that you want. We're going to have another window on the screen that's going to show only the hands on how to make it. I'm using blue, just it's easier for you to see, but even notebook paper will work. You will need scissors if you have them. If you don't have them, that's okay, because you can still tear off a part of your paper without using scissors. And then lastly, you're going to need a marker if you want to make a little fox face and some details for the eyes, the nose, and the ears, or however else you would like to decorate your fox. All right, so we'll give you a couple seconds just to get those materials ready. All righty, let's get started. So step one, we need to take our paper that is probably a rectangle shape if you're using a regular piece of notebook paper or computer paper, and we need to make it into a square. So the way that we're going to do that is to take our top corner and we're going to fold it down to the bottom edge. And again, you'll see it all on the second screen. So your paper should look like this after you make the fold. So this side part, this flap, this part you're actually going to cut off because we don't need it. And that is going to be just something you can discard, because once we cut it off, then we're going to have our square. If you don't have scissors, though, what you can do is you can fold it over like this, fold it over right along the edge, and fold it backwards and fold it back and forth a couple of times to make that paper easier to tear. And then you can just basically tear that strip right off. But I'm going to cut mine. All right, so go ahead and cut that side off. And then you have your square. So we'll give you a moment to get that part done. So now, if your paper was already a square, you're going to need to fold it diagonally and then unfold it so that yours has the crease down the middle like ours. So that's the next step if you started with a square piece of paper. And then after that, you're going to fold it in half the other way, diagonally, making it into another triangle. And now you're going to have that original crease down the middle from the first time that you folded it, and you're going to have a large triangle. We'll give you a moment to get that part done. All righty, the next step, we are going to take our bottom corners of our triangle down here, and we're actually going to fold them up to this top corner. So you're going to take these corners and fold them up and go ahead and make a crease so that they will stay in place. So now it should look like this. Kind of a square or a diamond, depending on how you're holding it. So again, take those bottom corners of your triangle and fold them up to the top. All right, and we'll give you a minute to get caught up on that step. Okay, so the next step is going to be not too tricky, but just have to make sure you're folding it in the correct direction. So you need to fold your paper in half again, but fold it backwards along that crease that was down the middle of your square between those two flaps. So fold it backwards. Go ahead and crease it down the middle, and then you have another small triangle. So take that square that you had and fold it backwards, and it's going to give you another triangle. All right, so once you complete that step, you're going to notice that on one side of your triangle, you have only like 2 flaps, and then on the other side, you have like a bunch of flaps of paper. So that's the side that you need to take note of for our next fold, because that's the part where you're going to do this next step. And I'm going to actually draw a line on mine so you can see where you need to fold it to get this step correct. So on that side with all those flaps of paper sticking out, you're going to make a fold that's kind of along this along the line that I drew with this marker. So you're going to fold it right there, fold it over, and then you're going to notice that it sticks out up over the edge, which is what it should look like. So on that edge that has all those flaps sticking out, go ahead and fold it from all the way down to that bottom corner, fold it up, and you'll notice that it sticks up over the edge. So I'll hold mine up so you can see it, and you can see it on the other screen as well, what it should look like. All right, so now you'll notice on that fold that you just made, again, there's all those flaps of paper we had mentioned a minute ago. These are actually going to become the face and the ears. So what you want to do is you'll notice there's 1, 2, 3 kind of corners there. Those 2 are going to become the ears, and the middle one is going to be the face. So you want to actually pull that apart in the middle and separate it. And you'll see the face start to come down. So when it starts to come down, just press it into place. And that becomes your little fox face and ears. So again, I'll show you that again. So once you made that fold so that it sticks up over the edge, you're just going to start to separate those pieces of paper. And that face is going to start to fold down. And you're going to want to press it into place. So it'll stay. And you have your fox face and your fox ears. We'll give you a minute to get caught up on that. All right, but now we need to help our little fox stand up because it's going to fall over if you try and stand it up right now. So we are going to make the tail. So I'm going to draw another line with my marker to show you how to make the fold for the tail. So you're going to fold the other side of that triangle right back over in front of the body. So it kind of wraps around the front. And that piece is what's going to help it to stand up. So again, just fold it right across that corner right across the front of the body. And that way, when you set it down, your fox can stand. And that is actually the last fold. All we have to do now is do a little decorating. So I like to keep my decoration simple. I like to do some eyes, a nose, and some ears, but you can get as creative as you like with decorating your fox. So I'm going to do that now with my marker. So I drew my little face, a nose, a couple ears, but I know that some people like to get really creative and do different patterns. If you want to make another one, sometimes you can draw a pattern on your paper before you fold it and then see how that looks once it's all folded up and made. You can do some cool stuff. Like our other one has that fun polka dot paper. So there you have it. This is your very own Catalina Island fox, and you can set it on your desk. And every time you see it, you can remember the amazing story of survival and recovery of our Catalina Island fox. We want to thank you for hanging out with us, and be sure to stay tuned this morning and come back on Saturday at 10 o'clock. We have 3 awesome channels of programming for you all, and we will see you then. Bye, everybody.
Thank you very much, Burton and Emerald Bay Outdoor Academy. Hope you all enjoyed it watching that, and I hope you can do that activity back in your classroom or at home today, whenever you get a chance. Speaking of classrooms, we want to talk to a few others out there. I know Florence Avenue Elementary School sent us the first little shout out, and that's to Miss Smith and Miss Blanco's class. That's in Local District East of LAUSD. Thank you for watching. Also, Liberty Boulevard School in Southgate, Robert Hill Lane, and Mrs. Mao's kindergarten class. Hey, kindergartners, how you guys doing? Hey. Mrs. Mao's class from Robert Hill Lane. Hope you're doing well this morning. Good morning. Gate Street Elementary School, room 38. So if you're in the school and you're not in room 38, you're missing out on this broadcast today. Also, Austin Elementary School with Mr. Arenas' class, 9th Street Elementary, and Jaime Escalante Elementary in Cudahy. It's the Jaguars 4th grade class. So all of you who are watching, thank you very much. I'll probably say your name again, or if you haven't sent us your name, do so in the chat. We'd love to hear from you. Don't forget. Yeah, hey, kindergarten class. Nice to see you again. Hey, you know what? While we're waiting for the next group to come on, let's enjoy a little, science has got a lot of dimensions. You can do a lot of things with science. You can discover things, observe things, build new things. But you can also be inspired to create art. And right here in our own Southern California region, we have some wonderful artists who get their inspiration from science, technology, engineering, and math, and then bring it back to use in math class. So enjoy this video from Music Notes.
Coming up, a middle school math teacher raps to garner his students' attention. And guess what? It works so well. Now he's on a nationwide tour with a stop in D.C. And today he's stopping by the Great Day Studio.
Sim King.
These fractions right here, I can compare any fraction, anytime, anywhere. Numerators the same, check out denominators. Which one is greater? Which one is smaller? Look at 2 whole pieces, cut them up in equal pieces. One made of 2 pieces, the other has 8. Which one is greater? Which one is less? 8 equal pieces are smaller than 2 equal pieces cut from a pizza. A fraction is something that's cut up into equal parts. Comparing 2 fractions, is this where you start? Numerators the same, look at denominators. Which one is bigger? That fraction is smaller. When comparing fractions, I have to use greater than, less than, or equal to. Look at the numerator, they're the same, so I look at the bottom. Ooh, I'll give an example. We both have an apple pie. I cut mine up in 5 equal pieces. You cut yours up into 3 equal pieces. Now take a look and see at what fractions we have. I have 1/5, you have 1/3. 1/5 is less than 1/3 because if you take one of my pieces and one of yours, my piece is smaller. Yep, comparing. I'll draw a picture to show all my work. Make diagrams, it'll help, it won't hurt. A fraction is something that's cut up into equal parts. Comparing two fractions, this is where you start. Denominators the same. Check numerators. Which one is bigger? That fraction is bigger. When comparing fractions, I have to use greater than, less than, or equal to. Look at denominators, they're the same, so I look at the top. Here's an example, 2/8 and 4/8. These fractions show how much cake we ate. Which one is less and which one is greater? Since we can see the bottoms are the same, the fraction is greater with the bigger numerator. 2/8 is less than 4/8. You can do fractions anytime, any place. A fraction is something that's cut up into equal parts. Comparing two fractions, this is where you start. Numerators the same. Look at denominators. Which one is bigger? That fraction is smaller. Last time, a fraction is something that's cut up into equal parts. Come on. Comparing two fractions, this is where we start. Denominators the same. Check numerators. Which one is bigger? That fraction is bigger. Yes.
There it is, yes.
Hey,
Oh, I love that.
because of that song, I was able to finish my homework.
Yes.
Lamar Queen, the rapping math teacher. Tell us how you got started.
My first year teaching.
Hello, everyone. Welcome to Crystal Cove State Park. My name is Caitlin. I work for Crystal Cove Conservancy, and I'm coming at you live from the coast in Crystal Cove State Park. We are located in Orange County between Newport Beach and Laguna Beach. And my job at Crystal Cove Conservancy is getting students like you involved in protecting all of the awesome natural resources we have here in the park through community science. So you all are going to be community scientists today. And what that means is you are going to be helping me to collect real scientific data to help study some of the ecosystems here in Crystal Cove and help protect them. So there are a few different ecosystems we have in the park. We have about 3 miles of undeveloped coastline. We also, at the south end of the park, have 2,400 acres of backcountry wilderness. And then our park actually extends offshore into the ocean that you can see behind me. About 1,000 acres of Crystal Cove State Park is underwater, and it is designated as a marine protected area. So since you're going to be community scientists today, one thing that I want you to have on you is some sort of piece of paper or something to write with. We got some planes flying over. And then the other thing is we also have Holly from Crystal Cove Conservancy in the comments on YouTube today. So if you do have any questions at any point, definitely feel free to pop those into the comments and Holly will do her best to answer them. So the specific ecosystem that I want your help to study today is our tide pool. So I'm actually going to walk you over to the tide pools. It's a windy day, but we can get a better look if we walk over here. All right, can you see behind me all of those rocks kind of at the edge of the coast here, right by the ocean? The tide pools are a really cool ecosystem because it's where the ocean meets the land. So right now it is high tide. And what that means is that the moon is pulling on the ocean in this direction, so our water level is really high. If you were to come back a little later in the day, more of these rocks would be exposed. And that means the moon is pulling it in the other direction of the earth, so our water level would be a little lower. And the really cool thing about these tides is that it means our ocean ecosystem is exposed and accessible to us for a good chunk of the day. So I'm going to walk back to my wind protected location here. So when our tide is low, people can walk down to the tide pools and see all of those animals that would usually be underwater, like crabs or sea stars, even some fish, trapped in those little pools in the rocks. So this makes it a really interesting ecosystem to study because it's the part of the ocean that is most impacted by people because we can get close to it so easily. So what I want your help with today is to actually study the health of our ecosystem and see if those humans are having any negative impact on our ecosystem. Now, it is really hard to do that by just going out and, collecting data on all sorts of different animals. There are tons and tons of different creatures in the tide pools, but we're going to study a specific animal today called an owl limpet. So this is just an owl limpet shell. Normally there's an animal inside here, and these will be stuck really tight to the rock. And this animal maybe doesn't look super exciting. It's not an octopus or a sea star or a fish that looks super flashy. You might not even notice this if you were to come to the tide pools. It almost looks like a rock. But they can actually be a really good indicator of how healthy our tide pools are. There's a few different reasons for that. So owl limpets, the animal inside here, a kind of snail, are what we call a souvenir species. And really what that just means is that it's really common for people to take them. With owl limpets, they're usually taken for food. So people will collect these from tide pools and eat them. Apparently they're pretty good to eat. The other thing about owl limpets is they grow to be really big. That's part of why they're good food. But people really just take the biggest ones. So when people come and collect all the biggest owl limpets, that can have a really negative impact on their population. So that's the reason they're really sensitive to humans. If we only take the biggest owl limpets, then there aren't enough adults there reproducing. So our owl limpet population kind of gets smaller and smaller over time. But the great thing about the tide pools in Crystal Cove and really our whole marine ecosystem is what I kind of mentioned earlier, that it's a marine protected area. So think for a moment, what do you think that means to be a marine protected area? So it's in the ocean, that's marine, and then protected means that we're limiting what people can do there. So like I mentioned, people like to take owl limpets to eat. But here in Crystal Cove, because it's a marine protected area, you're actually not allowed to take anything. So you can't collect animals for eating or for souvenirs. You don't want to take any of the other like algae or plants. You also don't even want to take rocks or shells. And part of that is because it's so easy for humans to access the tide pools, the ecosystem can be really damaged. We can harm a lot of the animals if we're taking them from our tide pools. So the marine protected area was put into place. There are marine protected areas throughout California. Crystal Cove is just one of them. And we're hoping that that will help protect our tide pool ecosystem and help keep these owl limpets in place, as well as all the other animals in the tide pool. But we don't actually know if our marine protected area is working. What we want your help with today is to study it and see how our ecosystem is doing by looking at these owl limpets. To really assess how our tide pools are doing, we have two different monitoring sites. So one is the one that I just showed you behind me at the very north end of Crystal Cove State Park. And then we have one farther south. So let's look at a picture at our two sites side by side and think about why we might want to study those two habitats and what they can tell us about our marine protected area. So when we're looking at the photo, what is the first thing that you notice? We have the Historic District site on the left and the Little Treasure Cove site, where I am, on the right. So the first thing that really stands out to me is that the Historic District site, you can see all of those people there on it. You can also see the little cottages in the background. Those are overnight rentals, so people can come stay really close to the beach. There's also a restaurant there, and it has really easy access to a parking lot. So it's one of the busiest parts of Crystal Cove. Thousands of people come throughout the year. There's probably hundreds of people there just today. Little Treasure Cove, when we went and looked over the side of the cliff here, did you see any people down there? Do you see any people in the picture of them side by side? So there's a couple reasons why we don't have people at Little Treasure Cove. When the tide is high, like it is right now, you actually can't get down there. You have to walk around a big rocky point to get there, so it's hard to get to. I'm also really far from the nearest parking lot, so this one gets a lot less traffic. That means that our Historic District site has a lot more human impacts than our Little Treasure Cove site. So if our marine protected area is working, hopefully we have healthy ecosystems at both of these sites. But there might be some negative impact at the Historic District site from all the people there. We don't actually know the answer to this yet. That's what we want your help to study. So what we're studying is how many owl limpets there are and how big our owl limpets are. And we do that at both of these sites. So before we get into measuring some of our owl limpets and counting our owl limpets, which is what we're going to do together today, I want you to stop for a moment and make a prediction to yourself. If we are to count all of the owl limpets at Little Treasure Cove and count all the owl limpets at the Historic District, where do you think we will see more? Do you think they'll be the same, or do you think one will have more owl limpets than another? How about where the biggest owl limpets will be? If we measure all of our owl limpets, do you think we'll have really big ones at Little Treasure or at the Historic District, or maybe think they'll be the same at both? So take a moment to think to yourself how you think the populations might be different at our two sites. So like I mentioned, we don't totally know the answer to this yet. We've been studying the owl limpets at Little Treasure and at the Historic District every year, and we're trying to track and see if there's any changes over time. And today you're going to help me collect data on our owl limpet populations at Little Treasure, the site right behind me. And so I measured some of our owl limpets, but what you're going to do is actually help record that data. You're going to be my data recorders today. But first, let's talk about how we set this up and how we study our owl limpets. So first of all, it's a really big area. If we counted every single owl limpet down there, it would take us hours and hours and hours. It'd be really hard to do. So we have specific sampling areas that we use. So let's pull up a picture of what our transects look like. So what that basically is we have a specific rectangle that we set out on the rocks in those tide pools, and we measure them in that same rectangle every single time. So you can see a big rectangular transect, and then it leads up to the ocean. And everything within that big rectangle, we're going to count all those owl limpets and write down how big they were as well. And then let's look at the next picture, which kind of shows you what that looks like actually in the tide pools. We have little bolts that are placed in the rock, and we'll just stretch out measuring tapes in between them. And that just makes sure that we're always measuring our owl limpets at the exact same place every single time. So we have one of these big rectangular transects set up here at Little Treasure and one at Historic District. In the picture, you can kind of see some scientists in the background measuring our owl limpets. All right, so once we're in that area and counting owl limpets, the next thing that I want to show you is how we keep track of them. So first, when I'm in that area, we need to find owl limpets. So how am I going to identify what is an owl limpet and what is something else? There are other kinds of species of limpets that have a shell stuck down to the rock, kind of like this. Owl limpets are definitely going to be our biggest ones. A lot of other owl limpets are smaller. And the other thing that helps you identify them is the shape. So some owl limpets are like triangular. They're like a volcano with a point at the top. This owl limpet, though, has its point up towards the front. So there's a point where it's really steep, and then it slopes really slowly down to the side. That's going to be your key feature if you're looking around that area to find all the owl limpets. Another thing that's helpful is you can kind of see it's like worn on the top. It's lighter colored here. That's an identifying feature. And then also just the biggest owl limpets out there are going to often be owl limpets. So once we find an owl limpet, there's one piece of data that we do want on it is we want to know how big they are, because that's one of the questions we're interested in studying, right? How big are our owl limpets at Little Treasure versus Historic District? So what we can use is calipers. So this is basically like a way to measure the size of something. So as you can see, when it's closed, there's a 0 mark here, and it lines up with the 0 on the little ruler. But as I start to open this, let me open it to 10 millimeters. So you can see the 0 has a little tick mark, and it's lining up with 10 on the ruler. So that means the area inside here is 10 millimeters. So we can use that to study the size of an owl limpet. So if we stretch out our caliper like this, then we can read where the 0 lines up with the little ruler and figure out how big our owl limpets are. And we're going to do that for every single owl limpet that we find. So we have a couple pictures that will help us practice that with an owl limpet that we found on the rock. So let's pull up our first picture that is just an owl limpet with some calipers on it. So go ahead and take a moment to look at it, find the 0 at the top, and see where the little tick mark lines up. The other thing to keep in mind is that we're always going to round up. If it's a little bit above a tick mark, we're going to round up to the next number every single time. So I'm going to give you a second to try to figure out how big this owl limpet is. All right, let's go ahead and reveal our answer there. How big was this owl limpet? It was 39 millimeters. So it was kind of between 38 and 39. So we're always going to round it up. And we're going to do that for every single owl limpet that we can find in the tide pools. And so what I did is I filmed a video a little bit earlier of me going out and measuring those owl limpets, but I didn't record any of that data. So what I'm going to need you to do is look at the calipers whenever I measure it, figure out how big it is, and record it on a data sheet. And you can just set that data sheet up on any piece of paper that you have. So now is your time to get that out. And then let's pull up a picture of our data sheet, and I'll describe to you what you want to write down before we get started collecting data. So at the very top of your piece of paper, you want to write Crystal Cove Owl Limpet Survey so that you can remember what you were recording down. You're going to write which site we are at. So the site is Little Treasure Cove. That is our low impact site because this is the site that is not as heavily impacted by people. If we were collecting at the other one, we would say Historic District. And then one of the most important pieces of data in science is going to be the date. So write today's date on your data sheet, March 24th, 2021. And then you just want two really simple columns. One for the size. So if I measured that last one that was 39, I would write down a 39 in that column. And then the next column is number of owl limpets. And this is where you're going to be tallying up how many owl limpets you find in that size. So like if I found one that was 39, I would write 39. And next to it, I would write one little tick mark. If I find another one that's 39, I would put another tick mark. So we're keeping track of how many owl limpets there are, as well as the size of them. And we can eventually compare between the two. So like I mentioned, you're going to be responsible for writing down this data. It's okay if you can't get every single one. We have a bunch of students watching this. So if you can figure out the size of as many as you can, that is awesome. And at the end of this, we actually are going to provide a link for you to submit this data to us because we do want to know. We want to know how big our owl limpets are and how many of them are here so we can compare it and see how our owl limpets are doing. So I'm going to give you one more second to look at our data sheet just to make sure you have that written down. And then the next task will be for you to watch me measure those owl limpets, record the reading on the calipers, and write that down on your data sheet. I'm going to basically teleport down into the tide pools down below earlier today, and we will check out what those owl limpets look like. Found like 3 owl limpets I can already see right in here. So I'm going to go ahead and use my calipers here, open them up, and try to measure from end to end on this owl limpet. It can be sometimes kind of tricky in the rocks. Hold on, I'm going to get a different angle. Okay. So then with our calipers, we're measuring, see where this 0 is at the top, that little tick mark. We want to see where that lines up to the millimeters up top. So right now, it looks like it's just a little bit above 35, so we're going to go ahead and round that to 36. So then what I'm going to do is on my data sheet, I'm going to write 36, because I found an owl limpet that was 36 millimeters, and then add a little tally mark. If I find any other owl limpets that are 36 millimeters, I can add another tally mark. Or if I find a different size, I'll go ahead and write that in here. So now let's go ahead and measure the other one here. Same as before. I'm gonna go end to end with my calipers. And then you're gonna read out from that 0 mark what tick mark it's going towards, and you can round up. So I'll give you a moment to look at that. Write that down in your data sheet. If it's the same size, you add another tick mark. If it's a different size, you can write that down as well. The other thing is once we've measured them, we're gonna use a marker. It's just a grease pen. It washes off when the tide comes in, but that lets me know that we measured it already. So I'll go ahead and do that for this one too, since you just measured that. Now let's do this other one here. Get that in there, end to end. And again, where that 0 mark, the tally comes straight down. Go ahead and write that on your data sheet. Cool. So those are 3 really close together. Let's keep looking for more, Eric. Scan around our rock. Oh, there's a big one over here. So here's another big owl limpet. We can tell it's an owl limpet because this really kind of point at the front. But you can see it's got a bunch of barnacles on it, which is really cool. But let's see how big it is. Okay, end to end. And then let's look at our calipers and go ahead and write that measurement down on your data sheet and add a little tick mark. And then I can already see another one right in here. So let's go ahead, measure end to end. Some of these are a little tricky to get in there, but I'll do the best I can to estimate end to end. Again, where that 0 mark comes down, and go ahead and add it to your data sheet. And then let's see, there's more over this way. Tons of owl limpets, you guys. All right. Calipers. This one's even has other owl limpets on it, I think. That's really cool. They're little friends. And then go ahead and again record with that little 1 mark, which tick mark it is. Awesome. Look at this little one hiding in the rock here. So we've got another one to measure. Okay, where that 0 mark reaches. Go ahead and record that on your data sheet. All right, welcome back to the top of the bluff. Thank you for joining me down there collecting data. I hope that that was fun for you all and that you had a great time recording data. Like I mentioned earlier, if you couldn't get every single measurement perfect, that's totally okay. That's the great thing about community science, is that with all of us collecting data, hopefully we'll together get all of the readings and the size of all of those owl limpets. So the next step that is a really important step in the scientific process is reporting your data back to us and then also analyzing it. So that's obviously not something we're getting into too much today, but if you visit our website, we're going to share a link both on the screen, and I think Holly's going to share that in the comments as well. You can enter the data you collected today, so the size of those owl limpets and how many there were, so that we can know how our tide pools are doing. We also had some UCI students out the same day that I was filming that video, so together we all measured all the owl limpets. As you can imagine, it's probably hard to tell just from what you measured how big those owl limpets were overall, or how many there were. But if we look at the whole data set of all the owl limpets down here, and if we compare that to data that we have also collected at the historic district, we can figure out which one has a healthier owl limpet population. And if you go to that same website where you can enter data, that's something that you can help us figure out. You can look at the larger data set and compare our owl limpet populations and see if they were bigger or if there are more here at Little Treasure or over at the historic district at the other end of the park. So that is the next step in the process, is analyzing our data, and then you can also share your findings with Crystal Cove State Park if you are interested, because that can help us better understand how people are using our MPA, if they're following the regulations, and if we have a healthy ecosystem here. So I wanted to thank you again so much for all of your help. Thanks for joining me here in Crystal Cove State Park. I hope that maybe someday you can join us in person and explore the tide pools on your own and see some more cool critters. All right, thanks so much, everyone.
Hey everybody, good morning. The morning continues. I hope you enjoyed that live broadcast from the beach, from Crystal Cove in Newport. I know it's down in Orange County and we're mostly doing LA stuff today, but that's okay. It's all part of Southern California. And you know, one of the great things about living here, as you may know, is that we can go to the beach and see sea science or ocean science. We could go up in the mountains and do outdoor ed and ecology. We've got wonderful high-tech stuff here. SpaceX, they're building rockets right down the street. There's all this great things in your own backyard. And, you know, places like the Columbia Memorial Space Center and Crystal Cove and Emerald Bay and all of these other places, we're here to help bring this to you. So I know that, know that we've been doing a lot of things online this year, and you're probably doing a lot of your school online right now. But when we are able to get back out there, you can come and visit our places, or we can come and visit you, or we do a lot of this virtual stuff. We can come into your classroom anytime. So please, let us know. We've got a great group of partners who are willing to always talk to classrooms like you, especially some of the classrooms who are watching right now, like Euclid Avenue Elementary School Magnet STEAM program. It's Miss Martin's second grade class in room 31. Hey, second graders. Christopher Dean Elementary School, a sixth grade class. How's it going? Nice to see you. Eastman Avenue Elementary, the second grade class. Another second graders. Woo! Mrs. Gonzalez's class. How are you guys doing? Thanks for being here this morning. And then Miss Ramos's second grade class too. So all of you out there, thank you very much for joining us this morning. And I hope you're getting a lot of great STEM and STEAM for your morning, waking you up in the morning. I wanted to, just kind of say that, it's a pleasure for us to be here today. This is all part of our City of STEM, our big science festival, which is going to be online Saturday from 10 a.m. to 5 p.m. And I want to remind you that the day starts off on Saturday with an exclusive conversation between Bill Nye the Science Guy and Kareem Abdul-Jabbar, the legendary Lakers player, who's also the STEM ambassador of California. It's pretty cool. We have astronauts going to join us. We have JPLers who just landed things on Mars. We have all kinds of great stuff for you. And also on Channel 3 on Saturday, we're going to be broadcasting STEM content all in Spanish. So you can always check that out too. That's at cityofstem.org. So teachers out there, make sure that your kids know that on Saturday they can get a little bit of STEM at cityofstem.org. We've got all kinds of great stuff for you today. I'm really, really happy to be joining you on your morning, a couple days before spring break, probably for many of you. Hope you're feeling good. Hope you're kind of excited about having a week off. I know I would be. I think I mentioned this before, but Los Angeles, your hometown, your area, has some fantastic people who are very creative and love to be inspired by science, technology, engineering, and math. We watched the video from this group earlier today. Let's watch another one. This is Music Notes, bringing math alive to you.
The song you're about to hear is based on true events. In the early 1950s, Marie Tharp's ideas were dismissed as girl talk. Last name Tharp, first name Marie with an expertise in cartography. Got a job mapping the ocean floor using sonar data from the Second World War, but she needed new data to complete her map, so they loaded up a research vessel ASAP. They sailed out on the sea, but they didn't bring along Marie. They didn't let women on the research vessel, so with map-making tools, Marie did wrestle. She showed it to a colleague, Bruce Heason. He said, Marie, you got no rhyme or reason. She caused a commotion when she said there was a rift valley at the bottom of the ocean. Girl talk. That's what the man said. Yeah, that's what the man said. He called it girl talk. Rejected like that. In 2 seconds flat, he called it girl talk. A valley with a rift implies continental drift. There ain't no place in science for your stubborn reliance on that girl talk. So Marie went back to the drawing board. Literally, she had a drawing board. She checked it once and she checked it twice. To be triple sure, she checked it thrice. She took it back and she showed it to Bruce. But this time, he called the truce. He shook his head, he said, Marie, I think I owe you an apology. Your map is right, yes, I must admit, but I'm worried that this map implies continental drift. They published it anyway, even though they knew the scientists were bound to say nothing but girl talk. That's what the men said, yeah, that's what the men said. They called it girl talk. Rejected like that. In 2 seconds flat, they called it girl talk. A valley with a rift implies continental drift. There ain't no place in science for your southern reliance on that girl talk. Still one man was intrigued. He was a well-known scientific celebrity. Jacques Cousteau was his name, and undersea exploration was his game. He said, I'll go into the sea. I'll be sure to take Marie's map with me. I'll film it for the whole world to see and settle this bubbling controversy. Socle bleu, how can it be? Everything's where Marie said it would be. The Rift Valley, every mountain peak, it's enough to make a man sneeze so weak. Because a revolution, Marie Tharp's girl talk was the solution. Girl talk. That's what the man said. Yeah, that's what the man said. He called it girl talk. With photographic proof, they learned the truth. They called it girl talk. A valley with a rift proof continental drift. She changed modern science for the silver reliance on that girl talk.
All right, that was the Amoeba People. Not Music Notes. We already saw Music Notes earlier, but that's the Amoeba People, a fantastic science rock band right in our own backyard. They're also the official house band of the Columbia Memorial Space Center, where I'm broadcasting from today. So check them out, the Amoeba People. They're super awesome. Teachers out there, download their music and use it in class. Both Music Notes and the Amoeba People are made up of teachers. These are teachers who have this fantastically creative musical side to them, and they bring STEM and math alive. So thank you, Amoeba People. I also want to shout out again, thank you to Crystal Cove for the previous video, Live from the Ocean. And sticking around in the science realm, I want to present our next piece of content. Our next program is going to be from the Discovery Cube. Now, the Discovery Cube has a site down in Orange County, and they have a site right here in Los Angeles, up in the North Valley. You should go check them out. They're going to be taking some Q&A, and enjoy Discovery Cube LA. Here they come.
Hi scientists, my name is Mrs. Erica and I'm from Discovery Cube Connect, your online science connection. I'm currently here at the Discovery Cube. We're not open right now as we're going under some major renovations, but I'm able to hang out with you here today virtually to do some really cool science. Today we're going to be talking about, can you guess? Bubbles. Bubbles are so much fun. I love bubbles. What do you think about when you hear the word bubbles? Here, let me help you. Using my homemade bubble solution, I'm going to blow some to you. What do you think about when you see these bubbles? When I think about bubbles, I think about colors. I think about all the different colors that bubbles can have. I think about the different sizes and how much I love to pop them. I noticed that bubbles are very easily popped on a windy day. What do you notice about bubbles? I am so sorry. Give me 1 second. Look who is at the door. It's my friend Blip. Can you guys say hi to Blip the bubble? Hey Blip. Blip, we were just talking about what we love about bubbles. I love the colors, and I like to watch the wind pop the bubbles. Oh, I see. Blip was just telling me how wind is the enemy of bubbles. Oh, heat is an enemy of a bubble? Ooh. Dry air is also an enemy of the bubble. Did you know that? I didn't know there was enemies of bubbles. When Blip mentions enemies, it reminds me of comic books and superheroes. What does it remind you of? Okay, give me 1 second. I'm sorry, Blip needs to go grab something. Blip, you're a superhero? Oh, now I get it. Okay. Introducing Blip the Super Bubble, fighting boredom and educating young scientists about bubble science. Is that better? Okay. Scientists, I want you to use your brain and I want you to think, what time of day do you think is better to blow a bubble? Do you think it's better to blow a bubble during the daytime or during the nighttime? You know, I don't actually know the answer. You see, I've never blown bubbles at night. I've only blown them during the day. But I wonder what would happen if I blew bubbles at night. Blip, I think I know what we need to do. We need to wait here all night to wait and blow a bubble at night. What was that? Blip, that's a great idea. We don't have to wait here all night to blow a bubble to see what it looks like in the dark. We can use science and science experiments to determine what that would look like. Scientists are people that study the natural world by using observations and discovering through experiments. That gives me an idea. Wait right there. Scientists can be superheroes too. Let's set up a super experiment to determine what it looks like when we blow bubbles at night. Grab your face mask and join us along on our super science journey. For this demonstration, I'm going to place a bubble in a box. First, I'm going to place some bubble solution on a plastic drinking lid. I'm going to blow a bubble onto the lid. After I've got my bubble, I'm going to close the flap on the box. Inside of my box, I've set up an iPad camera so that I can see what happens at night. What happened when I closed the flaps on the box? Could you see the bubble? No, we couldn't see the bubble because it was in complete darkness. I think this answers our question. It is better to blow bubbles during the day because you can see them. And at night, we can't see them because of the darkness. But now I'm sitting here wondering, what would happen if we blew a bubble in the dark at night, but there was a spotlight on the bubble? What would happen? Let's check in with our science experiment. Hey, super scientists, here's what I've learned so far. I can blow a bubble during the day, but that bubble may not be as colorful as if I were to blow a bubble at night with a light shining onto the bubble. It seems to me that the perfect time to blow a bubble is at night with a light shining onto the bubble, which is perfect because when the town is calling upon Blip the super bubble and super scientists, the spotlight they shine into the air will make a blip go beautifully and show all of their colors. Each year, the Earth circles around the sun one time. As it slowly moves, we start to experience changes in the temperature and we get different amounts of sunlight. This is what causes the different seasons: winter, spring, summer, and fall. Depending on where you live, these changes in seasons can be very different. In fact, when it is summer here in Southern California, it is winter in Australia, in South America. At the North and South Poles, they can experience days in the summer when the sun never sets, and days in the winter when the sun never rises. That sure sounds different than what we experience here. What are some things that change when the seasons change? When we go into a new season, we experience changes in temperatures, length of daylight, and air moisture. When I think about summer, I think about going to the beach for fun, the heat, and the smell of sunscreen to keep the long days of hot sun from burning my skin. Many of you have noticed that the sun rises much later and sets much earlier in the winter, giving us the appearance of shorter days. In the summer, it rises much earlier and sets much later, giving us much longer days. And the time just changed. How exciting for us to begin this journey. Longer days of daylight are great for bubbles. We can see bubbles longer during the summer. However, summer temperatures can be really hot, and hot air, as we know from Blip, makes water in a bubble evaporate and pop. In the winter, I think about cozy blankets, thick coats, and rain boots to keep my feet dry as I jump and splash into puddles. While it gets cold here in winter, it doesn't usually get cold enough for our rain to freeze and become snow. These temperatures are really good for our bubbles, but the length of daylight is short, making it a limited time to see bubbles. What about the fall? Leaves are changing, cooler temperatures, pumpkins. Sometimes in the fall, the wind will come racing inland from the desert toward the ocean, giving us strong, hot winds that often carry a lot of dust with them. Bubbles pop when they touch something that's dry and dirty, so they don't really like the Santa Ana wind conditions. Which season do we have left? Oh yes, spring. The days start to get longer in the spring, which means we have more sunlight than we do in the winter. Sometimes we even get spring rains to keep from getting too hot. Using what we just learned about the seasons, which season do you think is more bubble friendly to blow bubbles during? Winter, fall, summer, or spring? That's right, spring has all bubble-friendly elements, no enemies. There's not really much wind, it's not too hot, the days are longer, giving us more time to see bubbles. Spring is the best season to blow bubbles during the day so we can see them, or at night with a light shining on it so we can see all those pretty colors. That was so much fun, Blip. Thanks for coming over and showing us a super good time. That's all the time that I have for you today. If you hang on tight, my friends Miss Ari and Mr. R will come on and answer any questions you have about bubbles or about seasons. We want to invite you to have fun with bubbles year-round as a part of Discovery Cube Connect's Backyard Science Adventures. Don't have a backyard? Not a problem. All of the activities that you see on the Backyard Science Adventure unit can be done anywhere outside. Thank you for joining Blip and I today. Hang on tight for Miss Ari and Mr. R. I'll see you later.
Hi everyone, how's everyone doing today? So happy to be here with everybody. My name is Miss Ari, and I have my buddy.
Hi, everybody. Good morning. This is Mr. R here on behalf of Discovery Cube. Hope everybody's excited. I know I am, but get ready because we have quite a fun adventure for you folks. If you are ready, please give me a thumbs up because I know that I am ready. Woo. Are you ready, Miss Ari?
Mr. R, I am super ready for today. Now, I just heard that you friends just finished watching a really cool presentation of bubbles. And let me tell you, bubbles are super awesome. Here, let me blow some bubbles for you friends. Let's see. Whoa! That bubble looked amazing. And now, my friends, one of our buddies in our chat actually had a really interesting question for us. And if any of you other folks have questions for us, please make sure to type it in the chat to let us know. But this is our first question, Mr. R. Are you ready? Mr.
Oh,
R?
yes. Sorry, I just love bubbles so much. Once you said bubbles, I was like, bubbles?
Okay. Our first question actually comes from someone called Emmanuel Montoya. Emmanuel Montoya asks, what size can a bubble grow?
Wow. That's a question. So, first off, I've seen small bubbles. And I've actually been able to been placed or put somebody in a bubble. So the size of the bubbles can range. And so you can have little bubbles, big bubbles, and there's all kinds of bubbles. But as a reminder, everybody, the bubbles that we are going to focus on today are bubbles that we interact and play with, such as bubbles that are made out of primarily soap and water. But if we have time, which I know we will, I'm going to show you a great way for you to make a bubble solution at home. One of a kind, I promise. It's going to be a blast. But once again, bubbles can be small, big. I mean, I've even seen really huge, giant bubbles. It's true. Miss Ari, have you seen small bubbles or big bubbles?
I have actually. And actually, Mr. R, while I was doing some research, I discovered why bubbles get as big or as small as they are. So there was this scientist, and the scientist's name was Bernoulli, and he discovered this principle that said that when a gas is being trapped by something, it's going to push up, it's going to push down, left and right equally in all directions, and that's why we get the bubbles that we get. Our bubbles are the shape of a sphere. Now, of how big the bubble can grow, I heard that there's Guinness World Records. In fact, one of our world-renowned bubble artists, Feng Yang, has a world record of putting over 150 people inside of a bubble.
Wow, that's a really big bubble. I can't just imagine. Wow, that's a lot of people in a bubble. That is, and just to touch back upon what you said about the Bernoulli principle, you said, you know, as the air pushes, it can push up, down, to the sides, and so I was just thinking about that as I blow a bubble. Notice how the air is pushing this way, but sometimes the air pushes up, down. So let's just see that really quick. Check it out. And one other observation I like everybody to make is look at this. I'm going to blow very slowly, and then I'm going to make another bubble where I blow air faster. Let's see if there's a difference there. Maybe we can see a difference in sizes too. So here we go, everybody.
I love this experiment. Yes, let's do a trial on it.
All right, here we go. I'm going to go super slow with some air. Here we go.
Whoa, what about that bubble, Emmanuel? That was pretty big.
Yeah, and I noticed that if I blow air very softly and slowly, I get a big bubble. But let's see if I actually use my breath and go a little faster. All right, here we go, friends. Check it out.
Mr. R.
I'll try that again. I'll try that again. I know that didn't look here. I'll try that again.
Okay.
Okay. Well, okay. So I see I got a little smaller bubble. So it really does depend on how much air you place inside that bubble. So it makes it a little bigger, a little smaller. So I'm going to try one more time. And it seemed that it worked out much better when I took my time blowing a bubble. So when it comes time to blowing bubbles, take your time. Be patient. Enjoy the bubble. Become the bubble. Here we go. Whoa, whoa, whoa. Hey.
Whoa.
Hey.
Look at Blippi just showed up because he said that was a really big bubble you just blew. Well, Blippi also wants to give a huge shout out to Miss Garay Contreras' 3rd grade class at Eastman Elementary. So excited you were able to make it to our show today. Oh, and he's sure that he's going to be able to see you friends later because we're going to... Oh, yes. He heard that we're going to show them how to make that bubble solution. Now, Mr. R, Blippi, can I put you down for a second so I can show them my bubble solution? Oh, he says that's okay. Perfect. So... we have over here my bubble solution. And this is actually perfect because we just got a really cool question that came into the chat that is asking, why do bubbles have colors? So let me try to blow a bubble for you, friends. And I'm going to try to catch the bubble, okay? Just so that I can try to show you the different colors. Okay. Oops. You know what? If at first you don't succeed, you're going to try again. Okay, here we go. You see my bubble? You can see all the different colors. Oh, look, it looks like Miss Ari is in a bubble. Help!
It looks like you're an astronaut. That's what I would say.
It's one small bubble for mankind. No, one small bubble for me, one giant bubble for mankind. But okay, let's think about it. Why do we see all the different colors? Now, I think this has something to do with the ingredients, right, Mr. R? So can you remind us of the ingredients for bubbles?
So what you need in order to have bubbles is you need 2 main ingredients. Number 1, well, it's no surprise, you need water, okay? So you need water. Number 2, you need soap. So these are the two ingredients that you need in order to make bubbles. Okay. You need water and you need soap. And you may have seen this, especially when you wash your hands. Notice that sometimes when you wash your hands, you're using water and soap. And as you are scrubbing your hands, you see little bubbles that form. So that's a good indicator that water and soap are the main ingredients to having good bubbles. All right. And as you can see, Miss Ari is blowing some amazing, amazing bubbles. Look at that. Oh, there's a little bubble. I like that bubble. Oh, and hey, Ms. Ari, just wanted to let you know that somebody just showed up to my house, and you might remember this lovely gal. This is Dee Dee.
Hi, Dee Dee.
Hey,
Blippi was just here. You missed him.
Oh, Dee Dee, could you tell me something about bubbles that I don't know about? What? Oh, yeah, I know. I shaved. I know. You didn't recognize me? Oh, sorry about that. Yeah, everybody. I used to have this really long beard, and I shaved it. And Dee Dee's like, "That's not you, Mr. Art." Yeah, it's me, Dee Dee. All right. What? You brought something for me? Oh, what did you bring, Dee Dee? What did you bring? What? Why would I need that? Oh, hey, that's right, everybody. So Dee Dee told me something. Dee Dee said that if you ever want to make a really good bubble solution, another ingredient to add to your bubbles solution is sugar. Yeah. So if you happen to have soap, water, and some sugar, you can make some really cool bubbles. But as a scientist, I believe that if we want to see this bubble solution work, we must make the bubble solution. So check this out, everybody. Miss Jar happens to have some water here. All right, there we go. So we said we needed water, right? So I have water. Now I'm going to take some soap. All right, let's take some soap. And I am going to add some soap to our water. Yeah. Now, I always say this because many students have always asked, when it comes to an experiment, do you want to add a little bit or a lot? Well, I would say this. You start off small, because then if you add too much, it might be a little more challenging to remove that. Okay. So start off with just a small amount. So now, one of the things I will do is I happen to have my spoon. Allow me to mix this. And let's take a look. Let's see if it just works just with water and just the soap. Now I am going to borrow the wand that I was using earlier, and let's see if my bubble solution works. All right, here we go. Let's take a look. I'm going to try. Oh,
whoa!
Hey, that wasn't too bad. Look at that. Oh, cool. So it seems that if I just add a good amount of water and a good amount of soap, I can make a pretty simple bubble solution. But Ms. Ari, here, I'm going to let everybody know on something super cool. So Mr. R, he loves to conduct experiments, and he loves to conduct experiments with his son. And so over the weekend, I like to make pancakes for my son. So in the morning, I wake up, I make pancakes for him, and he loves it. And though I was thinking about this the other day when I made pancakes for him, we use something called syrup on the pancakes.
Oh, yes, it tastes so yummy.
Yeah, it's delicious. But I found out something you can do with syrup. So, well, here we go. So I happen to have some maple syrup. And as a scientist, I recall reading that if you add a little bit of something that's called glycerin to your bubble solution, it really helps stretch out the bubbles. But I don't have glycerin. And so I did more research as a scientist. And I found out that if you can find corn syrup, it will work. Well, guess what? I don't have corn syrup, but I have maple syrup. So I'm going to use the maple syrup. Here we go, everybody. All right. All right. Hey, by the way, if you add maple syrup to your bubble solution, don't eat your bubbles. They will not taste like maple syrup, okay? Here we go. As a scientist, we don't eat or drink our experiments. All right, here we go. Time for some maple syrup. Woo! Oh, wow, that looked cool.
That did look awesome, Mr. R.
All right, so now I'm going to mix this. La, 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 da, da. Sorry, I sing when I do experiments, everybody. All right, so here we go. All right. It seems solution is ready, I'm going to move my
Mr. Art,
time.
actually,
Yes, I'm sorry.
as I'm looking at your solution, it already looks like there's some bubbles in there. And that actually brings up a very important question. Actually, someone named Yvonne Flores is asking that are bubbles and boiling water oxygen?
Oh, that's a great question. Well, what's happening is this. If you ever take water and you boil it, what you're doing is you're applying heat to water and you're changing the water from a liquid into a gas. And what you're seeing is the gas, as it rises, it's still water. And those bubbles that you're seeing is because of the heat that we're applying to it. And that's a great observation. Ooh, we got some scholars in the house. I'm going to raise the roof for all the scholars. Oh, that is awesome.
My friends, yeah. So like Mr. R was saying, those bubbles that you see are a manifestation of the energy that we are adding into the water. So think about it, right? Think about your little water molecule. You're hanging out, you're having a good time, and then it starts getting hot. When it gets hot, you start moving faster and faster and faster until you turn into a gas. And once you turn into that gas, what happens is that you also make like a little gap, right? And that little gap could be perceived as those little bubbles as you're leaving. Think about when you're like splashing in a pool, right? Every time you go into the pool or you exit out of the pool, there's little bubbles to show that there was something missing there. Janet Rosas is really impressed with our bubbles. They're saying, how can they look cool? Why? How do they look so cool? And my friends, bubbles look really cool just because like we find bubbles just about anywhere and they're super fun. And we can do our bubble solution just like Mr. R was saying. Now, Yvonne, I see you also asked what the bubble solution was made out of. It's simple, just water, soap, and syrup if you have some called glycerin, or if not, you can even just add regular old sugar. But let's go ahead and let's continue making that bubble solution, Mr. R.
And so one of the things that I'd like to show everybody is that this bubble solution is really strong. And so what is happening is this, everybody. You may have seen in the video that our colleague put together, which she is awesome, Miss Erica. And so she talked about when a bubble actually bursts, what's happening is the water is evaporating. But another thing that you can do to prevent from the bubble bursting or evaporating is to make something in the water much stronger, something that's called surface tension. Ah, that's right. Many of you may have been to like a lake or a small pond, and sometimes you take a rock and you throw it across, and sometimes the rock goes pss, 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 and it skids across. Well, the reason that it skids across is because of the surface tension. That surface tension is like skin to water. And what happens is all the molecules, the little water molecules are like pushing up against each other, and that makes the water quite strong there. It is so strong that it prevents that little rock from going in. But if you take a rock and you throw it up into the air and it goes straight down into the water, you're breaking that surface tension. So a way that you can make really good bubble solutions is to make the surface tension much stronger. And so by adding this, it helps stretch out the surface tension. So that's what we're doing. But once again, look at my solution. And you know what, Miss Ari? We're going to go big. We're going to go big. I'm going to add some more maple syrup. Here we go, friends.
All right, Mr. Art. And while you add more maple syrup, I was actually taking a look at the chat, and Savannah asked us a really interesting question. Savannah asked, when are the bubbles stronger? Are they stronger in the night or the morning? Okay. And I think this is a really interesting question. And we can refer back to the presentation that we just saw, right? We discovered that the season of spring is the best time for bubbles because there's no bubble enemies present, right? So if you want to think about the daylight or the nighttime, well, at nighttime, what was going to happen to those bubbles, right? Without any light, we can't see the bubbles. So I think that they're probably strong both in the morning and at nighttime. Ooh. They might even be a little bit stronger because there's no sun in the sky to evaporate them. But
that's true.
Yeah, but the downside is that, well, we can't see the bubbles because it's dark.
Great
Ooh.
questions.
Yes, we're getting a lot of good questions over here again from Yvonne. Apparently, all of her children are tuning in. So shout out to Luna, Diego, and Ileana for tuning in today and helping us with our bubble presentation. They want to know if different types of bubbles exist.
Oh, that's a great question.
Well, let me think about it this way. Like, I know Mr. R and I have these fancy little bubble wands, but you can actually make your bubble wand all to yourself. So I have here some pipe cleaners, and I'm just going to make a very simple bubble wand to show you that all different types of bubbles do exist. There's actually lots of different places where we see bubbles, and it doesn't matter the shape of your wand. The bubble will always come out as a sphere. And it comes out as a sphere because of that Bernoulli principle. But I think you might be wondering, like, if other bubbles exist, then there do. There's air bubbles. There is different bubbles. Sometimes when you cook food, the pizza might have a little dough bubble, right? Basically, you want to make sure that there's gas present. Where there is gas present, there will be a bubble. And now, my friends, our time together is almost end, but we do appreciate everybody that came out. Mrs. Carrillo's class, 2nd grade at Pacific Boulevard Elementary, thank you for showing up. And thank you for the compliment. Eric lets us know that he really liked our lesson. Oh, look at that bubble. Oh, cabecita, cabecita. Oh. I was talking like soccer, right? He could like bump it with his head. So if you friends want to take more bubble adventures, Mr. R and I encourage you to visit Discovery Cube Connect. Discovery Cube Connect is going to be your bubble resource to an extraordinary amount of bubble solutions, tips, and tricks. You can even earn your very own bubble badge. I know I earned mine a couple of weeks ago, and I was so excited. Have you earned yours, Mr. R?
You know what? I'm working with my son so he can work on his badge. And what we've been doing is we've been going through all the activities. And as he saw me walking into the room, he's all, bubbles? And I said, not now, not now. And he goes, later? And I was like, later. So I'm definitely going to use the bubble solution that I made to play with my son during lunch. And once again, everybody, thank you so much for hanging out with us. It's been such a pleasure. We truly enjoy it. Thank you, thank you, thank you. And hopefully you can definitely check out, once again, Discovery Cube Connect for all those amazing lessons. It's such a pleasure to hang out with you, Ms. Ari, and everybody. We also wanted to have Ms. Little Dee Dee say bye. Bye, everybody. You're awesome.
Yes.
Wow.
Oh, sorry. Blippy wants to say something.
What's up, Blippy?
Oh, Blippy says that, remember, he need to fix his mask here. He says, remember, your bubble adventure doesn't have to end today. You continue blowing bubbles at home or even in the bathtub. Just make sure that you ask an adult if it's okay. But my friends, on behalf of Discovery Cube, the City of STEM, and all of you friends joining us, either from your classroom or your homes, we appreciate you all so much. We had super much time, and I'm glad you folks all enjoyed our bubble facts. It just goes to prove to you that, my friends, science is everywhere. And we are all scientists. Until next time, my friends, we'll see you. Stay curious, keep asking questions, and never take no for an answer, my friends. And make sure to invite Blippy over as soon as you can, okay?
Me too, Dee Dee.
Oh, bye, everyone.
Bye, bye. Let's go. Go, bubbles, bubbles, bubbles.
Let's go blow some bubbles.
All right, welcome back. Thank you, Discovery Cube, for that awesome presentation. I know you guys were working with bubbles and all kinds of great things. Discovery Cube, just another fantastic resource that the Los Angeles area has for STEM. You can engage with them online, and once things start opening up again, you can also visit them. There's lots of great stuff out there. So thank you very much, Discovery Cube. Hey, I just noticed that Ms. Contreras' class, her third grade class at Eastman Elementary School, have joined us this morning. How you doing, Ms. Contreras' third grade class? We have a homeschool class that's watching us today. In particular, Luna, Diego, and Eliana. Thank you to the three of you for watching this morning. I hope you're enjoying it. And also, I want to do a shout out to Pacific Boulevard Elementary School, Miss Carrillo's second grade class. Thank you for watching also. It's great to see all of you out there and interacting on the chat and having a good time. I hope you're enjoying it. Hey, this next thing, again, this is all part of the City of STEM Science Festival, which is a long-running program throughout Southern California for the next month or so. Our big program happens this Saturday online at cityofstem.org. We're going to be broadcasting over from 10 a.m. to 5 p.m. over 3 channels, all kinds of fantastic STEM stuff, including an exclusive conversation between Bill Nye the Science Guy and Lakers legend Kareem Abdul-Jabbar. It's STEM and sports all coming together in an awesome conversation. But we'll also have an astronaut. We'll also have an engineer from JPL who worked on the Mars rover. We'll have fantastic things like you're watching today, demos and activities. So join us on Saturday. One of the things that also starts on Saturday is the City of STEM Innovation Challenge. Now, this is for middle schoolers, so all the middle school students out there, pay attention. This is for you to put your thinking caps on and be creative and innovate LA for the future in a sustainable way. And you know what? Why don't you watch this next video to get an idea of what the Innovation Challenge is all about and how you can participate.
The 2021 City of STEM Innovation Challenge Sustainable Solutions is calling all Los Angeles County middle school students to help create a more sustainable LA. LA is the city of champions, but even champions face challenges like wildfires, traffic, and air quality. But bold solutions can come from anywhere, and we want to hear from you. Entering to win is as easy as 1, 2, 3. 1. Gather a team of 1 to 5 students from your school and create an idea for a more sustainable Los Angeles. 2. Create a 2-minute video that identifies the problem, the solution, and the potential impact for Los Angeles. Be sure to include the STEM needed to develop the solution. 3. Ask your parent to complete registration and video submission at cityofstem.org/innovation-challenge. The grand prize team will spend a day touring Los Angeles' top tech companies and will present their winning idea to STEM influencers, including me, Allie Ward, science communicator and host of Did I Mention Invention on the CW. LA needs your ideas to bring about a more sustainable future. Don't delay. Get started today.
All right. I hope that all of you middle school students out there, or if you have an older brother and sister or younger brother and sister who's in middle school, I hope that you accept the challenge, the City of STEM Innovation Challenge, and register. We officially announce the project on Saturday, March 27th, this coming Saturday, and registration begins soon after, and the whole challenge runs throughout the month of April. We're excited to see your videos and see how you would innovate LA. All right, we are about to get into the final part of our program today. This is coming from the Los Angeles Maritime Institute. Now, this group is down in San Pedro, and they actually run the tall ships down there. So these are large ships with masts and sails and the whole thing, kind of like a pirate ship. And they teach people or kind of take people through STEM experiences out on the ship, on the ocean. And they're going to come at you and talk to you about knots, because knot tying is very STEMmy. It's got a lot of math in it and some engineering in it. And it's also really tied to ships, to boats. So if you have a piece of string, those of you out there, if you have a piece of string or something like that, if you can get it, you can follow along with the LA Maritime Institute in this next bit and learn how to tie some really interesting, intricate knots. So without further ado, the Los Angeles Maritime Institute at City of STEM.
Hi, I'm Chelsea with the Los Angeles Maritime Institute, and today I am going to show you how to tie a Turk's head. Now, this is a fancy decorative knot that we use to tie around the end of things to hide any loose ends, but also when it's tied around you, traditionally on the wrist, but I wear mine on my ankle, it says that you are a capable deckhand. So you will need some seine twine or some sort of line, small line that you are going to use to tie it. I would recommend starting with something bigger if this is your first time tying it, and tying it around something to practice until you get the hang of it. And in order to tie it around your wrist or ankle, you're going to need 2 fathoms, which is an arm's length. The first steps are the easiest. And if this is your first time trying a Turk's head, you're probably going to redo them, or they're not quite the easiest. The second section is when it's easy because you're just following through what you did the first time. If this is your first time tying a Turk's head, probably gonna tie it a few times. I had to do this over and over many, many times until I finally figured out how to do it. It also helps if you look up how other people teach it, because this is just the way that I teach it. So what I'm gonna do is I'm going to pinch the end, and it doesn't have to be directly at the end. In fact, if you give yourself a little slack, it'll help come in handy later. And then you're going to let it come straight down your hand. And you're gonna go all the way around, and you're gonna cross over so that you make an X, and then you're gonna go around again to the outside so that you now have an I. So it's like XI. And then what I'm gonna do is I'm going to go, there's this one, which is my second one, is on top. Then my first one, it's underneath, is my first one, and it's underneath. So with my eye on the side there, I'm going to go under the first one and over the second one. And I'm gonna pull all the slack through. And then, using the legs of your X, you're going to cross them over, underneath to underneath, over top to over top, and that's going to trap your line. So you want to like push it through and see if it would look like it's going to slip through or not. That's how I can tell if it's going right. And then I'm going to shift a little bit so that I have this next space, and I'm going to go underneath, over top, all the way to the other side, pull through. So now I have that new section. Here's my first bit. Here's my 2 legs of the X, and I'm gonna do the same thing I did before, and I'm gonna cross them so that it's trapping it inside again. And I'm gonna shift. So now I'm gonna go underneath, over top, pull all the way through. Next one. Cross those, underneath, over top, pull all the way through. And however many times you do this, it's going to show in the weave at the end. You really don't want to do too many, because as you go through, it's going to thicken up with bands. So I recommend doing 4 or 5 going around. So cross it, underneath, over top, pull all the way through. And now, as you can see, I am back to where I started, because here's the little bit that I pinched off. And I can tell that this is a good one going around, because when I go underneath and over top, it is going to line up exactly with where I began, the end of the first steps. After, if you have it beginning like this, where it lines up to where you began, you can proceed to the next step. If not, you're gonna have to try again to straighten things out. Because now it's just following through that first one all the way. So here I am back where I began, and this is the beginning section. So if I go underneath and over top, it's going to lay right next to that first one. Just like that. So I'm just about to start my second go round, and I can tell that because now here is the first time I started following, and here's the second time I started following. This is a good chance for you to check the fit of whatever you're going to be putting this on. Let's say I was going to put this on my wrist. That's a pretty good fit. Lots of space in there. As you keep going, this is going to tighten down. And also, anytime you get it wet, it is also going to tighten down. So as you're beginning tying it, make sure it's nice and loose. Otherwise, you will cut off the circulation. Don't do that. Do not cut off your circulation. And it's always underneath, over top, all the way through. I'm just gonna keep following it. And you wanna make sure that you lay it neatly next to it as you go, because that's gonna help make it look pretty at the end. Doesn't matter if you're on the inside or the outside. The line is gonna kind of tell you where it wants to lay. It's also really great if you, it's much easier if you like tie it around someone. So like get a friend, teach them how to do this, and they'll tie theirs on you and you tie yours on them. Because tying it around yourself is no fun. And you're gonna have to like use your teeth, and don't put Saint twine in your mouth, it's gross. Third time around. So now I've got 3 laying next to each other. 3 is good. I think that's where it starts like, I would say that's probably be, if you want it to be decorative, that'd be about the minimum that you would do. Looks nice. Most people do 4, depends on how you're feeling. Or maybe you just don't like the number 4. You can do 5. You can do as many as you want to fill in the space. It depends on where you're doing it. If you're doing it around as a bracelet, I would recommend at least 3, probably 4. Occasionally you'll have to like flatten, squish them so that they flatten out and still lay pretty. And it'll be easy to tell when to stop because you want to keep all of the ones equal, and eventually you'll start going around and one will be different. Or you can also look at that first bit that she left hanging out and just tuck it around behind. Look at that. Ta-da! Back at the beginning. See? There you go. And look at how much that tightened down. I really struggled to pull it back on my hand the third time. But first time it slid right on. Oh yeah, no worries. But then it just got tighter and tighter. And I could still actually take this one, put it on or put it off. Depends on how tight you want it. The one around my ankle I tied pretty tight because I never take it off. I just leave it on all the time. I just wanted it to stay. So it's on there. And you can always adjust the tightness at the beginning, which is also why you should get a friend to help tie it on you, because they'll find it easier to tie with 2 hands than just one. You should not just leave your ends hanging out there. I would recommend trimming them nice and close. Usually we don't tie them together. I always just clip it and then burn it a little bit at the end and squish it down there. But that only works if you're using something synthetic. If you're using a natural material like hemp or cotton, you can tie it together. Great. So that's how you tie a Turk's head. If you have any questions, email us at asklamy@lamytopsail.org. Or you can come out and learn in person and go sailing with us.
Hey everybody, I hope you enjoyed that video on knots from the Los Angeles Maritime Institute. By the way, if you go to the Los Angeles Maritime Institute webpage, or LAMI, L-A-M-I, their webpage, you can find that video and you can do the knots at your own pace and at a later date. Well, hey, that was the last big piece of programming that we have for you this morning. We really hope that you enjoyed it and that you had a great time. You know what? I'm going to take a moment and I'm going to say thank you for watching Florence Avenue Elementary School, Liberty Boulevard, Robert Hill Lane, Gate Street Elementary, Austin Elementary, 9th Street Elementary, Jaime Escalante Elementary, Euclid Avenue Elementary, Christopher Dina, 6th grade, Eastman Avenue Elementary, another Eastman Avenue Elementary, Pacific Boulevard Elementary, and the homeschoolers with Luna, Diego, and Eliana. All of you, thank you and all the rest of you, thank you so much for watching this morning. I just wanted to remind you that this is part of the City of STEM Science Festival, which is all virtual and online. It kicks off with a huge event this coming Saturday, March 27th, starting at 10 a.m. We're presenting all day on 3 streams STEM content that includes a conversation with Bill Nye the Science Guy and Kareem Abdul-Jabbar, the Lakers player, an astronaut, an engineer from JPL, the host of the Ologies show. We have many more activities and demonstrations from museums and universities and other groups around Los Angeles. One whole stream is going to be done all in Spanish. We're featuring girls in STEM and women in STEM all weekend. Please tune in on Saturday for the City of STEM Science Festival, and you can find out more information about that at cityofstem.org. I want to say thank you so much. Also, thank you to all the crew here at the Columbia Memorial Space Center who got this thing together, especially Noah and Laura and Monica and Diana and Rick, everybody who helped make this morning possible. I really appreciate it. Again, my name is Ben. I'm the president of the Columbia Memorial Space Center. We are the Space Museum and Hands-on Science Learning Center, ready to interact with you and have a great time. Don't forget to watch City of STEM this Saturday, March 27th from 10 a.m. to 5 p.m. online at cityofstem.org. Thank you very much for being here, everyone. Have a great rest of your day and have a wonderful spring break. Talk to you later. Bye-bye.